Section 3.3 is going to be talking about how we discuss skewed data. So we're still talking about numerical data, but now we're going to look at data that's left skewed and right skewed. So when we're looking at data that's left skewed or right skewed, so I'll draw a picture right above here. So for example, this is right skewed. What happens is that our center, or most common value, would be here, but since this is right skewed, our mean would actually be over here. So what that means is that we can no longer talk about the mean because it doesn't represent the same thing in skewed data as it does symmetric, which would be the most common value. So instead, we are going to think about the median. Now remember, what the median value is it's going to be the middle value if we organize the data from smallest to largest. Don't forget, if we have an even number, we're going to take the two middle values and take their average. So here is an example of why we use the median and not the mean. So here we have a histogram that has the scores for a class. Okay, and this would be, what do you guys think, left or right skewed? This would be left skewed. And what we can see from this is that around 28-ish students got more than 56.666 on this quiz. And then after that, we only had about 1 or 2 students get any scores below that. So before we move on, a big question that people ask is why we don't use the mode. So we don't use the mode because we aren't guaranteed to have one. Man, aren't guaranteed. I am so bummed right now that I don't know how to spell guaranteed. Anyway, aren't sure if we'll have one. So we aren't guaranteed, or we aren't sure that we're going to have one, because to have a mode, you have to have the exact same observation multiple times. So what can happen is that either 1, we only have every observation once, or 2, we have so many different observations that occurred multiple times, the mode becomes meaningless. That's why we use the mean. So we have the raw data below for the histogram that we saw above, and what we can see is that the average is about 56.6, so what we saw above. The median is 60, and the mode is also 60. Okay, we have a standard deviation of 6.8, and then kurtosis, that's not something we're going to talk about in this class, so don't worry about it. Now, here's the issue with this, is that even though our mean is 56.7 or 56.6-ish, more than half of our data is actually above that percentage. So what that means is that that's not a typical score. So it's not a good representative of what most people in the class got. Also, if we're still interested in how much of our data is gathered around the median, the standard deviation doesn't apply to skewed data. So if we look at the quiz above, let's try to think about why that is. If we look at the data above, then by the empirical rule, we should have 68% of our data between, and it should be between about 49.8 and 63.4. Okay, so why is this an issue? Well, the reason this is an issue is because we have way more than 68% of our data falling on that interval, and the empirical rule says we should have about 68%. So just because we have more observations between those two data points doesn't necessarily make it a good thing. What we want is we want accuracy. The other reason that this is not a good interval to use for skewed data is because 63.4 wasn't even possible. So the highest somebody could get on this quiz was actually a 62. Nobody got anything above that. So it is inaccurate for both of those reasons. What we use instead to talk about the spread of our data is, instead of using the standard deviation, we use something called the IQR, aka the interquartile range. Okay, so when we're using the interquartile range, aka called the IQR, what we're going to do is we're going to take our data and we're going to cut it up into 25% chunks. Okay, I'm trying to highlight, but I'm accidentally crossing things out. So when we cut these into 25% chunks, what we're going to do is we're going to list them from least to greatest, and then we're going to cut it up into fourths. So we're going to have the first 25%, the first 50%, and then the first 75%. The interquartile range is going to be the difference between the top 75 and the bottom 25. So just to kind of give you a real example of where you've heard quartiles before, if somebody says that they're in the 95th quartile of their class, that means that they scored higher than 95% of other students. Okay, if you're in the 25 percentile, what that means is that you only scored higher than 25% of students, etc., etc. So it has to be in order from least to greatest. We also have something called the range, which is where you take the maximum value and you minus the minimum value. So let's consider this example where we took a sample of coffee prices from a class and we had 15 observations. So if I have 15 observations, I want to cut this into fourths. So whenever I cut anything into fourths, I like to cut it in half first. So we have 1, 2, 3, 4, 5, 6, 7, and the 8th observation will be the middle. So next I'm going to cut this part in half. So I have 1, 2, 3, 4, 5, 6, 7 observations. So my fourth one will be the middle there, and then 1, 2, 3, 4. So what this does for me is it's going to give me the first fourth of my data, then it's going to give me the second fourth of my data, and the third fourth, which will be Q1, Q2, and Q3. So when we label these, we are going to have, let me get rid of that first. We are going to say our first quartile is going to be 2.3. Our second quartile, this is also called the median, is going to be 3.5. And Q3 is going to be 4.5. And the IQR is going to be our third quartile minus our first quartile, which is going to be 2.2. So it's really great that we can find all of this data and we can find all these numbers, but the most important thing ever in stats is context. So what does this mean? It means that the middle 50% of our observations will be about $3.5 and differ by at most $2.20. So what this is doing is that it's saying, hey, if you look at any of the middle 50% of people that we interviewed, okay, the most common price that they're willing to pay for a cup of coffee is going to be $3.50. And the most these people are going to differ in the price that they're willing to pay is $2.20. So what that gives you is it's going to give you a typical value and some idea of the spread. Now what that leads us to is, how do you decide which way you're going to describe your data? Are you going to use the mean and standard deviation, or are you going to use the median and IQR? So here's the first thing you're going to do, is you're going to look at the shape of your data. If your data is relatively symmetric, Then what that means is you're going to use the mean and the standard deviation. Remember, we're talking about how you describe a typical value and the spread. Now, if your data is either left skewed or right skewed, then what you're going to use is you're going to use the median and the IQR. So remember, the median is describing the typical value of the data, while the IQR is describing the spread. Now, something to remember is if you were looking at left skewed versus right skewed versus symmetric, sometimes there's a numerical way to tell which one is which. So the numerical way you can tell is data is going to be symmetric if the mean is pretty close to the median. It will be left skewed. So remember, this is going to be your median. It'll be close to the center. Your mean is going to be pulled to the left. So what that means is that the mean is going to be less than the median. And here, the median is going to be by the center, whereas the mean is going to be pulled to the right, so the median will be less than the mean. So these are nice ways to decide if it's left or right skewed if all you have is the data and not a histogram. Another reason that you would want to use the median instead of the mean is if you have outliers in your data. So let's say that we're looking to purchase a home in a neighborhood, okay? And what we find is that the homes are 253,239, 240, 220, 290, 4.3 million, so obviously an outlier, 274, and 289. So we have an outlier. Now what I want you guys to do, using StatCrunch or by hand, is find the mean of the homes and find the median. Okay? We want to know which is the better representation. So what would be a better representation is the median. The reason the median is better is because the mean is high due to the outlier. So the key takeaway from this is that if outliers, perhaps it's a good idea to use the median, especially if you feel like you have a lot of outliers or too many, or you're not allowed to remove them from your data for one reason or another. Use the median. All right, last but not least, what if our graph is bimodal or multimodal? So what happens if we have a graph like this? Which one do we use? Do we use the mean or the median? Well, actually, there's not a clear answer here, and the reason that there's not a clear answer is because usually what happens when you have a bimodal graph is that you have one group and then you have another group. So what you should do if you have a bimodal graph is you should try to decide what the two groups are. So maybe they're male and female, maybe they're adults and children, maybe they're different cultures, and separate them and analyze each one of them individually. Okay, so maybe you're going to want to use the mean for both of them because they're both symmetric. Maybe you're going to want to use the median because one of them is skewed. So the key is, if it's bimodal, separate them into different groups. Now what I'd like you to do is I'd like you to pause the video and try this next example on your own and see how you do. I'll give you a hint before you get started. N, the sample size, is 33. Alright, so what we want to do is find the median. So if the size of our sample is 33, what we want to do is find the middle value. You can do that by taking 33, dividing it in half, and then rounding it up. So 33 divided by 2 is going to give you 16.5. So that means that our 17th observation is going to be the middle one. So if I count all the way up to 17, I'm going to land on 7. So the median, which is called Q2, is 7. Is the data symmetric, left skewed, or right skewed? Well, I could create a histogram, or I could say, hey, the mean in this case is less than the median. So the mean was 6.06, the median was 7. So if I just look one screen above, that tells me that this data is left skewed. So that means that our data will look like this. Okay, great. Now, if we were asked to give a summary of the data, which would we use, the mean and the standard deviation, or the median and the IQR? Well, since the data is skewed, we would use the median and IQR. So, just as a quick summary, we would use the mean and the SD if we have symmetric data, which means that we can use the empirical rule. And if it is skewed, we are going to use the median and IQR. And remember, what the median IQR is that it breaks it down into percentiles. So that's the middle 50%, this would be 25%, and then this would be 25%. Okay. Also, use the median and IQR if you might have an outlier. Great, what we're going to be looking at next is what do we use instead of a histogram to graph or get a visual representation of the median and IQR, and that is going to be a box plot.